Hey everyone, welcome back to the On the Go podcast. This is season 2, episode 2, and really excited to really start the conversation about something I think is really important to everyone, impacts everyone on a daily basis, traffic signals. And we have a plan for that. We're looking at how we can make our traffic signals smarter, more connected, to better serve all of you as you're traveling across Contra Costa County. And with me here today, we've got 2 experts that are working on this fantastic project that we're going to talk about more with all of you today. And the first one is Matt Redmond he's the traffic engineer for the City of Walnut Creek. You wanted me to introduce yourself, Matt, and talk a little bit about yourself?
Yeah, so I worked for the City of Walnut Creek for 6 years now, and enjoying managing and operating the traffic signals, and taking a safety first approach to all the projects that we have.
Yeah, awesome. And we're going to learn more about Walnut Creek. They are really one of the early adopters of a lot of this new technology and getting it implemented, in Contra Costa County and in the City of Walnut Creek. So there's been a really great partner, working with you on this project, Matt. And with us also, Andy Dillard, our senior engineer, really the person responsible for making these projects really happen. So Andy, you want to introduce yourself?
Sure, thanks, Tim. Yeah, Andy Dillard, senior engineer with the Authority. It's been almost 2 years now. I've been with CCTA. Previously, I was the transportation manager with Town of Danville. I was there for 28 years and oversaw our traffic operations. So I'm very excited to be on this side of the project and delivering this on behalf of the county.
Yeah, and thanks, Andy. We're really excited to have you at CCTA. It's been fun working with you on this great project, and just all the experience you're bringing from the local jurisdiction side into the project, and working with Matt and everyone has just made the project that more successful. So before we get into the conversation, we really want to talk a little bit about the history. I think the first traffic signal, you might wonder, where was the first traffic signal? And we did a little bit of research, and we found it was in London in 1868, and this is a picture of what the first traffic signal was, and it was essentially a manually operated traffic signal. And at night, it had red and green gas lamps to be able to see the red and the green at night. And so this just gives you an example of just really how far we have come in terms of what we had in the past and what we're working with in the future. And that's what we're really excited about, is really what the future is. The other thing about traffic signals is a big part of this is really thinking about safety. On our roads in Contra Costa County, traffic signals and intersections claim about 40 to 60 lives per year, and about 25% of that is actually pedestrians and bicyclists. And so we are really focused on safety. That is our number one priority and goal in Contra Costa County as we kind of think about this. And we're doing that through a vision. And that vision is called Vision Zero. Vision Zero in Contra Costa County, which CCTA adopted about 4 or 5 years ago, is really focused on how do we reduce our fatalities for everyone in Contra Costa County and getting to 0 fatalities in Contra Costa County. And we feel that traffic signals are really a key component to that, and how we can make our traffic signals smarter to be able to achieve our goals around meeting Vision Zero and improving safety. So as we kind of talk about that and think about that, I really want everyone to kind of we'll start talking about Vision Zero, we'll talk about the project, and then we're going to talk about vision. And so first I'm going to turn it over to Matt. Maybe you can talk a little bit about why Vision Zero is so important to the City of Walnut Creek and why this project is really helping to support those goals.
Yeah, a lot of part of my daily job is interfacing with residents and learning about different issues on our streets and in our traffic network. And we're limited in what we can do today, but I think what this project does is allows us to kind of have insights into what's going on our streets before people call us, so that we can be more proactive rather than reactive to a lot of these safety events on our roadways.
Yeah, and I think it's really important, right? I mean, as you think about that, we want to make sure, I think proactive is the key word there, right? I think what we want this project to do is right now, and I know we'll get into little details later in the podcast, but I think our existing system, the way it works today, is it's not necessarily reactive, right? We want to be proactive. We want to be responsive. And I think technology has evolved, obviously, since 1868 about how to do that. We have adaptive signals now, and now we have the advent of connected signals and AI, and I think there's a whole nother next generation of traffic signals that we're really excited about. And the way we're doing this is through our Countywide Smart Signal Program, right? Our Countywide Smart Signal Program was a project that CCTA took on, And we looked at how do we upgrade and really connect the entire traffic signal system across the entire county, right? So we're talking, I think we have about maybe 2,000 total intersections in Contra Costa County. There's about 1,200 that are signalized. And of those 1,200, we're really focused on these like large arterials and routes of regional significance. And of that, we're talking roughly about 365 signals that CCTA is investing in and working with all 19 cities and towns and the county to be able to bring this system to reality. And the person that's working on that is Andy. And so Andy, maybe talk a little bit more about this project and why it's so important for Contra Costa County.
Sure, very important at the local level as well as the countywide level. So at the local level, it's really bringing all the systems, the hardware, the software, really into the 21st century. So upgrading all the signal networks, and then also, as you mentioned, tying in all those local networks at a countywide level. We're going to have a center-to-center system that's going to help oversee this network. It's going to provide upgrades to all the signal detectors, all the advanced traffic controllers that are in the cabinets that make all the decisions in the field for the traffic signals. It's going to provide battery backup systems, improved network communications, and it's also going to provide, which we'll talk about a little bit later, transit signal priority and emergency vehicle preemption. So.
And I think what's really important about this, right, is people who are driving, right, in Contra Costa County, the roads don't stop at city boundaries, right? And I think that's the key here. We have 19 cities in Contra Costa County, and I think the key here is that we're making sure that we have safety, reliability, and efficiency in the entire network in Contra Costa County, and making sure that everyone is able to get around, and not just within their local jurisdiction, but also when they're going to another local jurisdiction. Because I know, I live in Pleasant Hill. I go to Costco in Concord. And I got to drive through, Pleasant Hill, Concord, all the way to Costco, and so that needs to be coordinated, as we're kind of traveling across, boundaries, right? And so as we kind of think about that, these routes of regional significance, right, and these major arterials, maybe Matt, talk a little bit about like why is this important for City of Walnut Creek and how this project is really important for these large arterials. Like, I know everyone faces traffic on Ignacio Valley Road every single day, right? And so it's probably one of the single biggest, complaints that I get sometimes about, oh, what's that traffic? And so I think, tell us a little more about why this project is so important to these large arterials and these routes of regional significance.
Yeah, I think the way we classify roadways in Walnut Creek, it's like collector and neighborhood streets and collectors and then arterials. And then we have this other classification called the route of regional significance. And those are the Ignacio Valley roads, the tree boulevards, and sections of North Main. Ignacio, for example, that carries over 70,000 vehicles every day, across it. And so when we're dealing with that type of volume, we really need to provide technology that coordinates the signals so that the green provides a progressive green throughout the corridor so vehicles can travel smoothly across it. And you're so right about the connection between other agencies because, people don't care, residents and visitors don't care if it's another city and they have to stop at red lights because the agencies don't talk to each other. And I think that's a huge benefit where CCTA can overcome that and look at these corridors from a system-wide perspective to help optimize that.
Yeah, and I think it's great. I think what we want to do is really optimize the connectivity, right? And making sure that people have just this kind of uniform experience through the entire corridor. And I think, and we'll get into more in terms of the exact details of what this project's going to do. And I think before we do that, what we want to do is really just play a short video to kind of talk a little bit about the project, give you a visualization of what this project actually is, and then we can talk more about it.
Ever sit at a red light when nobody's around? Our traffic signals weren't built for how we move today. That's why CCTA is upgrading hundreds of intersections across Contra Costa County to create a connected network of smart traffic signals that communicate and coordinate in real time. Outdated signals slow us all down. They bog down our commutes, make it harder for buses to stay on time, and leave pedestrians and cyclists waiting around for lights to change. Smart signals can detect vehicles, cyclists, and pedestrians and share that information across the network instantly. That means traffic engineers can coordinate timing and adapt to real conditions, helping traffic flow safely and smoothly. These upgrades also prepare our roads for the future. We'll see faster emergency response, faster transit, and safer streets for everyone. A safer, more connected, more accessible, and smarter way to travel. CCTA.
Okay, so hopefully that gives you a visualization of like what this looks like and gets you excited the same way that we're excited about this project. This is, again, really kind of helping all of you on a daily basis. I mean, nothing drives me more crazy when I'm sitting at a red traffic signal and there's no traffic at all, and you're like, why am I sitting here? Why am I sitting in this red light, right? And so I think we know the frustration, we hear the frustration, the three of us live it every single day, and we're excited about this project. So let's roll up our sleeves and we can nerd out on this a little bit, get technical, have fun with it, and we can talk about the project. So I'll turn it over to you, Andy. Let's tell us a little bit more. What does smart signals mean? Like, what does that actually mean to someone or the individual, and what can we do with it?
Right, so smart signals really means that it's a proactive system. So as we talked about at the top, current systems the signals work on fixed time. This system will provide adaptability. It also, an important component of it is the reliability of the system, as well as integrating the pedestrian and bicyclist detection capabilities that it has. That's really, to me, an exciting piece of this project. It provides better detection for our pedestrians and bicyclists, and it also gives us back real-time data to see what's happening in the field. So we'll be able to evaluate near-miss situations at intersections, which is really important for traffic engineers to make decisions to better optimize their signals and make them safer. Really, it provides better coordination amongst the signals that we talked about across those cross-jurisdictional boundaries, which really helps improve traffic flow throughout the entire county, not just within the cities that they serve.
Let's start with the basics a little bit. So when you say that the traffic signal is on this like fixed timing, what does that actually mean? I don't know who wants to take that question, but maybe Matt, you want to take that question?
Sure.
Yeah, I mean, let's just maybe get down to basics a little bit, because I think it's important for the public to understand, like, how do signals work today, right? And then how does this project going to improve them, right? So let's talk a little about what the signal system does today.
Sure. I think a great example actually in Walnut Creek for fixed time signals is in our downtown. So we have, Main and Cypress and Main and Bonanza, and these signals are very, very simple. They just turn green, yellow, red, and then the other phase turns green, yellow, red. And so it's just switching back. And so those time values are just programmed in as a set value, and they just do that every day, all the time. They do not understand the traffic conditions that are going on. They don't know if there's no pedestrian buttons. They just automatically turn on the pedestrian phase. And so they're very simple in that regard. So that's an example of basic timing.
Yeah, so if you think about that fixed timing, right, the fixed timing, I think what you do is so if I'm sitting there at a traffic signal and the turns red, you're just waiting for the signal to turn green, right? And that's a fixed time, whether that be 2 minutes or 3 minutes or 4 minutes. And so the City of Walnut Creek would do like a little analysis based on what those conditions could be, and since you can't react to what's happening every minute, every hour, you kind of have to look at the system overall and kind of make some assumptions of this is to address all conditions throughout the entire day, this signal timing has to be 2 minutes or 3 minutes, right?
Yeah, I mean, if you look at a corridor like Ignacio where we do time the lights, we do a study looking at traffic volumes and understanding the counts of vehicles across the corridor. And then based on that, we make decisions that will then be implemented in those signals for the next 2 or 3 years until we come back and look at it again. And so it's very much, set it and, monitor it, but pre-program it and based on that 1 week of data collection. And so it's pretty limited in regards of what we can glean from that 1 week, and then modify accordingly if things change a little bit. But really, I mean, that's how it is for a few years until we come back again with another project to retime it.
Yeah, and I think the key there is data, right? That's the key, is data. And so now what we're doing with this smart signal system is we're putting in additional devices and cameras
Yeah.
to be able to detect
Yeah.
and get more data.
Yeah,
So
so-
talk to me a little bit more about that. Like how do we, what types of devices and things we're putting in the intersection to get more data and better data so we can help solve this problem, right?
Yeah, we refer to that as high resolution data. So the new video detection systems, the advanced traffic controllers, those give the ability to have these adaptive type systems so they can react to what's happening in real time versus, as Matt explained, predetermined timing patterns based on a previous study that was done 1, 2, 3 years ago. So it adapts in real time. So the equipment that's available to us now, the hardware and the software in both the form of the video detection systems, the controllers, and then and even the advanced traffic signal cabinets, working all together provide us with that, again, that high resolution data that both gives us the ability to make more real-time decisions, as well as allow the system itself to make those decisions to optimize the signal at all the intersections and throughout the corridor.
Now that we've collected this data, right, through all this detection, new detection systems and so forth, so I guess the question is how are we going to use that data to now solve this problem and in terms of improving the traffic signal system?
Yeah, I mean, the data can be used in multiple ways. I think one way is to have it automatically collect the counts. And so the counts aren't based on 1 week of data. They could be based on the past 3 months, and you can continually use those. So you can do it in that form. I think another aspect of this project is, especially with the near miss insights, understanding where potential collisions may have occurred, you can start to understand which countermeasures we can implement so that we don't see those type of events again. Do we need to add, reflective tape around the border of the signal so that people can clearly see those, or something to address, a common systemic issue at that intersection? So I think that's an approach.
Yeah, and it's a great example, the near miss data. Another implementation measure is what we call leading pedestrian intervals. If there's repeating incidences of near miss collisions, we can provide that additional walk time for pedestrians to get out into the intersection and clear the intersection more safely. So all this data comes back to the traffic engineer, allows them to analyze that and make those decisions. So it's really, again, going back to safety with this project, it's really probably the biggest benefit of this project is improving safety.
So what I'm hearing, that I want to talk more about near misses, because I think it's important for the public to kind of understand like what the near misses are and like how we're detecting those near misses and why smart signals and the equipment we're adding is able to do that now, right? And so now we have better data to improve the signal timing, to make it more reactive and more responsive, to help with congestion and help with the daily driving. Now we have better data to making sure we detect incidences in a better way, right? And so that way we're improving the safety of the intersection. So, I know I ride my bike, to work, and, I would love for the intersection just to detect me, right? So I don't have to go over to the curb cut and push the button, it'd be great if so by having better detection of bicyclists and pedestrians and the cars in real time, how do you detect near misses? What does that mean?
Yeah, so we talked a little about pedestrians, but bicyclists too. It's really important. So as you mentioned, going back to the detection piece of that, a lot of complaints that we hear at the city level is I'm not getting detected on my bicycle. So not to get too into the weeds here, but old school detection is the inductive loops that are in the ground. With these modern video detection systems, a bicyclist can be sitting in an intersection by themselves and get that detection, whereas now it could be rather problematic for them to get that detection. In addition to that, on the safety side of things, also when a bike is detected, it can provide information to that traffic signal controller that they're going to need a little extra time to clear that intersection and get through it safely. So it's about efficiency, again, reliability, that the bicyclists can rely that they're going to get that detection, and then the safety component that they're going to be safe going through that intersection.
So in the future, can the traffic signal system, is it able to detect a pedestrian, walking across the street, and then is it able to adjust the signal timing based on people walking across the street? Because I know we all don't walk at the same, I walk fast. I know other people may walk slow. And so can the signal system even respond to something like that?
I think that's the goal. I think what Andy was saying with the bike, if it detects a cyclist, it can give a certain time to cross the intersection, versus if it's a vehicle, it doesn't need as much time. But then also with the pedestrians in the crosswalk, if they are taking more time or they drop something and they needed extra time, and the video sees that, it can extend the signal to delay the green light of the opposing phase.
Which improves safety.
Absolutely.
Right? So make sure that the signal is responding to what's actually happening, in the intersection, right? Which improves safety. I think the near miss, is really interesting, because we have all this detection, now is the intersection the detection able to see where those near misses are? So a near miss might be like, oh man, a car came really close to a bicyclist, or something like that. So can the system detect something like that?
Yes, absolutely. So it's a combination really of the video detection and the softwares that we're implementing with this. So it can identify those types of situations, and most importantly, it can aggregate that and give it back to the traffic engineer in a report format so they can easily analyze. It's easily digestible, not only for a traffic engineer, but for the public to understand. So that data that comes back, it allows the traffic engineer to make decisions to extend timings or adjust timings accordingly to improve safety where you have those recurring issues of near miss situations at intersections.
So we've been working on this project for some time now, and we actually selected a partner in this called Dirk. And we have a video we want to share with you to be able to kind of illustrate and visualize everything that we just talked about, because I know it can sound confusing, it's very technical, but we want to be able to show you exactly how does this detection work? Like how does the software and the cameras detect all of these things that are happening at the intersection? So why don't we go ahead and play that video? So what's important about that video, as you can see, is that basically immediately using AI can detect what's happening in intersections. So you've got a pedestrian, a vehicle, a bicyclist, and it's able to track that movement in real time, through the intersection. And I think what's important about this, and this gets back to the safety component, is you notice those red dots in the video. Those red dots then get cataloged, and now we have a historical reference of every single near miss that's happening in every single intersection at every single day. And then what that does is it helps us prioritize, right? To be able to be more proactive, right? Rather than being reactive and waiting for these reports to come in on these incidents and accidents, now we can be proactive and be like, wow, there's something happening here at this intersection every single day. We need to invest our funding here, our sales tax dollars here, Measure J dollars here, to be able to improve this intersection, to improve the safety. So how would we do that? How would we actually do that?
Well, I think what you're saying there with that video, it shows two people or two modes traveling and a point where they intersect or almost intersected. And I think what Dirk provides is then like a heat map of the intersection, and so providing essentially like a hot yellow, like a red or a green area of the intersection where a lot of those dots are occurring. And then we can start to break those down and say, hey, was there a lot of cyclists at these events or pedestrians at these events, and really dive into what's going on. Now, this is much more rich data set than one person calling and saying, this happened to me. And so it allows us to really try to address the root cause of what's going on at that intersection to improve safety for all the users.
Yeah, and I think that's really exciting. And I want to talk a little bit more about what you're doing at the City of Walnut Creek. I think you're leading the way, in the county in terms of all this technology. I mean, I think Ignacio Valley Boulevard is one of those like really already smart corridors, and I know Walnut Creek was one of the first kind of even early adopters to test new technologies around connected vehicles and working with Audi and those things. And so you guys have been really forward thinking. So talk a little bit more about what you're already doing, and how Walnut Creek is already kind of moving in the direction of kind of being this smart city?
You want to take this one, Andy? Gosh. So, yeah, I mean, so Walnut Creek has a history of, trying out new technologies and seeing what else is possible, given that our roadways are constrained. We can only do so much in the built environment, and expanding those are costly or prohibitive given the available space we have. And so looking at technology as a possibility for improving safety or improving efficiency, allowing us, so one thing Walnut Creek has is our signals are connected back to City Hall as well as our courtyard. And so that allows for engineers or our technicians to monitor the system and understand, if things are properly working, or if we need to change something, we don't have to go to the field to change it. And so since everything is connected over, high-speed networks, it allows us to stream video or understand if the video detection is working properly, and or changing timing parameters remotely. And so all this allows us better insights than, traditional cabinets.
How do you use, what kind of tools do you use to help optimize the signal system? So using simulation, different types of tools. So what types of tools are you using to get, knowing that data is really key to this, right? And making sure you got the right data to adjust the timing and all those things. So what does the city do in terms of the simulation and the tools you use to kind of optimize what you already have today? Because in Ignacio Valley Boulevard, I know you're already trying to optimize to the extent possible, right? To move people as efficiently as possible through Ignacio Valley Boulevard, right?
Yeah, there's a few tools, and a lot of it goes back to that original data set where you put that in and you can analyze. So a tool we use is Synchro, where we can take in all this timing data and vehicle count data, and we can display it in a way to understand if that will progress vehicles through multiple signals. So to get more technical, we look at a time-space diagram allowing signal phases to be shown, as well as vehicle trajectories to be shown across them. And so we can ensure that vehicles are not stopping when they're able to travel through multiple signals at once. So that's one tool. And then we also look at the high-resolution data from the controller, and we can plot charts and understand if that timing is as effective, or if we can make other modifications to those timing parameters for Andy was saying with the leading pedestrian intervals, or if we have a high number of pedestrian calls, should we be looking at, and right turns, should we be looking at a leading pedestrian interval at this intersection? So various optimizations and safety improvements through those.
So we've talked about kind of the connectivity, the timing part. We've talked about the safety part. I think the third part of this is really the priority part. Right? So now that you've got all this infrastructure now in place, now we can really talk about how we want to use the infrastructure to prioritize, certain vehicles through the routes of regional significance and the arterials and the intersections. And so we're talking about transit, we're talking about emergency vehicles, and I think, I know one of the biggest risks for an ambulance driver is that, they're running their signal and they're trying to run down this road, and the light's not turning, it's red, and so the other's green, and so they've got to safely navigate, across these intersections in a safe way, so they can, so by having emergency vehicle priority, we can now have faster response times, and improve safety and health, in Contra Costa County, working with our emergency service providers. So let's talk a little bit more about that. All right, so one other use case that we didn't really kind of talk about is that I think is really supportive to the emergency vehicle priority, emergency response is evacuation. So I think one of the key things about this project is that as we get to this countywide traffic signal system, supporting use cases like countywide emergency evacuation. And as we all know, in our county, we've got a lot of local communities that are prone to wildfires and other emergencies. And so we want to be able to use this system to be able to react to that. So as countywide, county fire is responding to a local incident or wildfire, we're able to sit with the fire chief and be able to activate our signal system to provide, response times and coordinated response times to be able to evacuate people efficiently and effectively, and that goes both with just vehicles, but also with transit, so as we're sending in buses to evacuate people or, prioritizing vehicles. So one example of that might be that we, take a roadway, like Moraga Way, and we just turn it all green, right? And we're flushing, people out of those areas, onto like Mount Diablo, and then able to coordinate that and flush it green all the way to Highway 24, and so that's just a really good example of like how we can use this system to coordinate connectivity from residences to local roads to arterials to the highways, and be able to flush out and flush all that traffic out during these emergency situations, and so how do you think the system, Andy, would maybe be able to support that or react to something like that?
Sure. So in addition to the software side and monitoring side, if the signals aren't operating, then none of that technology is really helpful. So one of the important key components of the countywide project is implementing or upgrading battery backup systems. This allows a signal to keep running when there's a power outage. So in a lot of these evacuation situations, the power has likely been cut for whatever reason. So these battery backup systems gives you additional runtime, so the signals can continue to operate and communicate back to the center-to-center system or whatever system is managing the response. So it's a very, very key component and important component as far as evacuation, and that's part of the countywide project.
Yeah, and even earthquakes, right? I mean, if you got a big earthquake and you're doing some major evacuation or anything like that, any disaster really. I mean, if the power's cut, this battery backup system would be really key to making sure the systems continue to operate. So I think it's just such a great use case of, the signal system and CCTA's role as a countywide transportation agency to be able to support this countywide, coordinated effort, right? And working with the county and working with the Office of Emergency Services and working with emergency responders is just a great use case, for this countywide smart signal project.
Yeah, and another use case that you'll cut out is if a Taylor Swift concert comes over to the pavilion, and having that get out all at once and making sure that we can flow vehicles through the city.
Yeah, and as we got major events, right? I mean, we have major events. We've got concerts, right, at the pavilion in Concord and other places, and so and it could even be like a local event too, where you've got a lot of like maybe Lafayette does its art and wine festival that has 60,000 people that attend that event every single year, and so that could impact adjacent cities and the highway, and so having a system like this can help support events throughout the entire county.
Yeah, and having a local system, I mean, it really doesn't solve that problem. You really have to look citywide to be able to go across boundaries to coordinate that movement, all the way to the freeway or wherever you're trying to get them. So just the local system that we have now would be very limited in that case.
And I think that's another key important part of this project, right, is the local system and upgrading the local system, because I think, not all cities have this like really advanced local system.
Sure.
And local active traffic management system. And so I think a key component of this is making sure everyone's kind of at the same playing field, right? And everyone's kind of playing together on the same playing field with the same connectivity. And so maybe Andy, talk a little bit about that. What type of local investment is needed, to really get everyone at the same standards?
Yeah, that's a great question. So yeah, very important component of the project we call it Advanced Traffic Management System, or ATMS, and a lot of these systems now are cloud-based. So there's little hardware that's needed. Before, you needed a lot of servers and technology to get these things up and running, but now it's very, very easy to implement for especially some of our smaller agencies or cities and towns. They're going to be able to see their systems that are connected, their intersections connected as part of this project, and get all that real-time information and be able to monitor their signals. If anything, just get alerts and alarms that there's an issue at an intersection so they can better respond to that. So some of the cities have those as part already, but as part of this project, some of the cities are getting these brand new systems. So basically every city in the county is going to have this ATMS system when the project completes. So.
Yeah, and that's exciting because I mean, you can then make the changes in the office, right? I mean, that way someone's not having to go out to the traffic controller and with their laptop and make the adjustment in the field. They're able to do it at the desk, which is also safer and also efficient, right? And it helps, you know, the traveling public to have those better response times. So it's really exciting. Yeah, these are some great use cases. I mean, evacuation, the events, all of those things I think are really important, you know, benefits of this project. You know, so I know we've been working on a transit signal priority project in Walnut Creek. And I think that's a project that we're doing in partnership with County Connection and you in Walnut Creek. And so let's talk a little bit about that project.
Sure. So yeah, the Transit Signal Priority Project, in Walnut Creek, we deployed that on 2 routes in our downtown, so routes 4 and 5. They run transit signal priority to allow them to extend an existing green call. So you could imagine a bus approaching an intersection. If it has a green light, it'll essentially extend that green light by a few seconds to ensure that bus gets through the intersection. Now, if that bus arrives on a red light, it will try to shorten the other phases by a few seconds so that it can get an earlier green. And so if you do that over multiple signals, you can ensure that the bus stays on time, you know, keeping that bus, keep the bus on schedule, provide a smooth ride for the passengers, and overall try to improve ridership.
Yeah, and I think that's really key. I think the hardest part about transit is that transit is sitting in traffic, you know, and so I think the ultimate goal is, I mean, people feel challenged in terms of taking bus in the transit is because they feel like they're just sitting in the same congestion as if they were sitting in their car, right? And so I think the goal here is if we can get transit to go faster, you know, than the car, then hopefully people then, you know, take the bus and be on and get higher ridership, right? And so with this project, you know, we did this pilot with City of Walnut Creek. I think also the City of Concord as well, right, with County Connection. And so we signalized how many intersections was it? It was 31 intersections, and then we equipped 59 buses, right?
Yeah,
59 buses. And I've got the facts right here because I can't remember all these facts. And so we did a study, and so what was interesting about the project is that for everyone out there, we got 17% reduction in bus signal delay, and we also got 6% reduction in bus travel times, and we got higher on-time performance, fewer late departures, and also improved progression through the signals to have better on-time performance. And I think for everyone out there that's really concerned with all the environmental, and so as we are at CCTA, it's one of our goals to kind of reduce emissions in Contra Costa County. We were able to reduce roughly over 300 gallons of fuel by just making the bus go faster, right? And so I think that's huge, right? And I think, and in terms of like user benefit, we're talking almost like, you know, $4 million of user benefit, you know, over the next 10 years. So it just demonstrates the benefit, you know, of transit signal priority. And as we think about that, I want to talk a little bit about, you know, the future, right? As we think about the vision, right? And I think where we're going with this traffic signal system, because I think it's important that people realize that this smart signal system is really just a foundation, you know, to a much bigger vision, you know, as we kind of think about all the use cases, you know, that we can use this system for, you know. One, we can use signal timing and AI and help connect things together. I think the important thing I think is also to realize is, you know, we're not widening ourselves out of congestion. You know, like it would cost us millions of dollars and lots of impact if we were going to go widen Ignacio Valley Boulevard, right? That's not happening anytime soon or at all. And so we have to figure out a way to manage what we already have, the infrastructure we already have, and try to do that as efficiently as possible. And this smart signal program is really the first step. It's the key foundational piece, because what it does is it allows us to be able to connect to all these signals, see what's happening on the ground in real time all day long, you know, and collect this data and be able to start building like an actual, what I call digital twin of the infrastructure, you know, and we can see what's happening, right? And so as we think about that, you know, how we're going to leverage that in the future and all these different use cases, you know, and I think maybe, I don't know if either one of you take this, but just like, for example, like the emergency vehicle priority, I mean, that's a key component to this. I mean, if we can provide safer routes, like let's talk a little more about that use case and how it actually would work throughout this like system.
Sure. So one of the benefits of the TSP system that we're implementing, it's cloud-based. So it's expandable. That's, we're preparing ourselves, as you said, for the future. So this is really the first phase, this project, but we're hoping to expand TSP and emergency vehicle preemption to a cloud-based system also. This, just like our traffic signals where they can communicate across city boundaries, our cloud-based system can also operate across city boundaries as well as transit agency districts. So we have 4 transit agencies in Contra Costa County, and this cloud-based TSP system will be able to work with all those different traffic signals and transit agencies. So emergency vehicle preemption as well. This project includes hardware and software upgrades, and it's also going to prepare us for future deployment of cloud-based emergency vehicle preemption as well. So, and again, that would communicate across all the different emergency response agencies, not just one, but all the ones in the county. So,
Can I talk a benefit about the emergency? So what's great about the cloud-based emergency vehicle preemption is it allows for advanced routing of the vehicle so right now with our current emergency vehicle preemption in Walnut Creek is it's line of sight based. So essentially there's a little device on the traffic signal pole that shoots out about 2,000 feet and detects a fire truck or ambulance, giving a green light. And so it can only be detected when an emergency vehicle is approaching. Now with the cloud-based solution, you can predetermine where you want to go, and those lights can determine when to turn green to either flush out traffic. So you can imagine a busy corridor during the weekday. It could flush out the traffic, preparing for the emergency vehicle to come through. And then it knows about left turns that it wouldn't have line of sight of otherwise. And so you can kind of get improved efficiency for response times on that.
Yeah, now you're getting me excited. Because I think the key here is that we got this cloud-based solution, and now we're doing this center to center communication, right? So CCTA, working in collaboratively with all the cities, we've got this countywide traffic management center, and then the emergency providers have their dispatch system. And so if we can connect those two together, right? Now we know when a fire engine is going to be dispatched, and then we can then route that fire engine based on current traffic conditions, right? Or other incidents that may be happening in the corridor. Mm-hmm. And I think the other cool thing about that is then you've got these really cool, movable, geofences that be able to inform even future vehicles, right? As we start thinking about connected and autonomous vehicles, right? I think it's making sure that there's a cloud that's kind of informing all vehicles of what's happening in the system, right? And so then you start thinking about okay, this fire engine is now going to be dispatched from point A to point B. We're going to route it in the most safe way as possible, most fastest way as possible. And now we're prioritizing just a green wave, right? And so we're in the system, we're able to see this fire engine kind of move through the system, and we're just tracking that green wave, all the way through the system. It's safer for the ambulance driver and the fire engine driver, and then it's also safer for everyone else out on the roadway system. And so that's the holy grail, right? I mean, that's the holy grail of this system, and that's what we're ultimately trying to achieve in the future as we kind of start thinking about, moving to more of these cloud-based and center-to-center systems. And I think what's exciting is the Countywide Smart Signal Project is really the foundational piece to get to that vision, and what's also really interesting and exciting is that this is not unprecedented. There are other cities in the world that are already doing this. Right. I already know that the city of Amsterdam is doing this with a program called Traffic Talks, and they already prioritize emergency vehicles through their corridors. And Amsterdam has actually one of the most unpredictable traffic signal systems in the entire world because it's literally changing signal timing in real time to adjust to real, travel conditions, right? Real-time travel conditions. And so that's where we're going, and it's exciting that this project is taking us there, right? It's really taking us there. So as we're kind of thinking about the future, being able to prioritize movements, being more dynamic, being more responsive, all those things. I just want to start maybe closing things out, on the podcast. What are some of the, like for you, Matt, like what do you want the public to see relative to this project? Well, let's talk a little more about just on the ground benefits, right? Like, why are you excited about this project and this program?
Yeah, I would love for, visitors or residents to feel like they're protected when they're on a bike going through an intersection for the Smart Signals project, or going through a crosswalk. They feel like, oh, I'm not having to keep my head on a swivel to look out for objects because they know they have a clear and safe path ahead. So having that sense of comfort, I think, is really strong. And then knowing that we have additional data insights into making improvements and prioritizing improvements throughout the city to allow everyone to feel safer in the traffic network.
Yeah, and I think it's having those direct benefits. That's really what we're all about. We want to make sure everyone is getting a direct benefit to the work that we're doing, with CCTA and our partner agencies. So as we kind of think about that at the city level, let's talk more about the county level. So Andy, like at a county level, what is getting you excited about this project?
Absolutely. So it's exciting to think that CCTA can take a larger role in helping cities not only monitor their systems, but actually help out operationally in the future as well. All the things we talked about with TSP, EVP, have some oversight with that and to assist with cities with managing those systems. There's a lot that the cities have to do on a day-to-day basis. So it's exciting to think that, CCTA is going to start taking a larger role in that. One of the really important aspects, I think, too, is, we talked about how Walnut Creek is so advanced with their traffic operations. So kudos, Matt. But some of the cities, they're just now implementing their local traffic management systems. It's going to provide better reaction times for maintenance crews to get out and fix problems. CCTA can also take a bigger role in that too with the center-to-center connected system. It's going to be able to allow us to monitor what's going on out in the field too. And if not operationally, we can certainly reach out to cities and connect with them and say, hey, we have an issue on this road. Can you maybe go take a look at that? So, really, this is really a partnership, this project, and it's just the beginning. So we're really excited in that regard.
Yeah, and I think the part that makes me really excited about it is just having better information and better data, for the county. And I think what's important about that is, making sure with that data, we're able to do better planning, right? Mm-hmm. We're able to do better planning. So as we have more information on the ground, we can decide as a CCTA, as an agency of like, hey, we can help prioritize certain things and we can do better planning and better understand like what are the needs of Contra Costa County, and I think that's really important because I think one of the things that I think we're interested in, and I know the public's also interested in, is like making sure we get that high return on investment on every public dollar that we're investing into the system, right? And so making sure by having this data and making better decisions and planning better and doing that planning, we can sit there and say, okay, if we do this project, we know there's going to be countywide benefit, and be able to see what that benefit is across the entire county and see what that return on investment is. And I think that's really important as we think about the future and measure and implementing, public dollars through Measure J and also through sales tax. And so it's really exciting. So I really want to thank everyone here today to listening to the podcast. I hope you enjoyed the podcast. I hope you enjoyed getting to hear from Matt and Andy about the project. Any closing words or anything, Matt, Andy, on anything?
No, thanks. I want to commend CCTA for leading this effort. They're essentially doing most of the work on that, and it's nice to be able to review the plans, send them back, and know that they're pushing the ball forward to get this project completed. So it's been a great partnership. I know even with the TSP project, similar, we have our set of work, and then working with them or with you guys, we're able to deliver the project on a timely manner.
Yeah. Thanks, Matt. No, we're excited to work with the partners.
And likewise, on the other side, the cities and the towns, it's been a lot of work to get to this point with this project. It's been several years in the making, but the input and expertise that they've lended to this project, really, really appreciate it. I think in the end, it's going to be a fantastic project, and hopefully there's going to be more to come.
Yeah, and I think this is we're just getting started, right? And so hopefully you all can see there's a vision. This is the first step in that vision. And I think the important thing is that we know that this is an important project, I think, to all of you as we think about the traveling public in Contra Costa County. And it benefits everyone because everyone drives. Most people drive in Contra Costa County. And so thank you for listening to On the Go Season 2, Podcast 2. Hope you'll be able to tune into the next episode. And thanks for tuning in.